Assalamualaikum and very good morning to everyone. My name is Syed Muhammad Hanif bin Syed Baharudin and my friend is Muhammad Nur Afiq bin Hasni and Muhammad Hafizul Hisham bin Muhammad Zaid. Today we want to expose on the application of the Kit 4.0 high voltage construction kit, which is the latest technology from Hafley Hypotronics, Switzerland. The system integrates state-of-art technology, offering variable frequency experiments to students with adequate security circuit. It integrates a frequency converter front-end, digital oscilloscope for voltage, current measurements, and a completely refreshed accessory set. The Kit 4.0 is powered by a frequency converter, a device to convert grid frequency and voltage to another frequency and voltage. It is used more and more often in a variety of applications as the knowledge about it has matured as new control circuit has become available. Frequency converter makes for a compact and clean power supply and competently replace traditionally used voltage regulators and motor generators. For this laboratory one, we have to trace and provided with clear circuit. Labeling, remark clearly type of cable, color and description of each type of circuit. There are 5 circuits we have to elaborate, which is power cable circuit, lamp and alarm circuit, interlock system, emergency button and grounding system. Each type of circuit have different purpose and have their own different safety requirement.
Hello, Assalamualaikum and very good day to everyone. Today I will talk about switch on procedure. There are 9 steps. The first one, open kit control software according to its manual. Next, make sure no humans are in the danger zone. Then make sure that everything is connected properly. Number 4, remove ground road from the system. Number 5, be sure that the test area cannot be entered during operation. Then unlock emergency button. 7. Switch on the low voltage. Close the primary breaker at the key frequency converter by key control software, according to the key control software manual. Number 8. Set the key FC cabinet in the ready. Press ready button. And the last one is switch on the high voltage. Press HV on button. HV means high voltage. Okay, settle the switch on procedure. We go to next procedure, which is switch off procedure. In this procedure, they have 6 steps. The first one is switch the output voltage at the key frequency converter continuously to 0 by the key control software. The second one, switch off the high voltage. Open the secondary switch at the key frequency converter by the key control software, according to the key control software manual. Number 3, press emergency button. Number 4, open the interlock. Interlock is safety secret contact. Number 5 is all high voltage parts have to be ground with the grounding load. And the last one is follow the 5 safety regulations. Okay, that's all the procedure. Thank you.
So, this lab generally is to familiar and adapt the safety knowledge and the SOP for handling the high voltage laboratory work. After that is to do the troubleshooting task for recognizing the important section of high voltage instrumentations. In this lab, we will expose on the application of the Kit 4.0 high voltage construction kit. This kit powered by a frequency converter, which is a device to convert grid frequency and voltage to another frequency and voltage. The number one task is to trace power cable circuit. So in this lab, we're using high voltage transformer model PZT100. For this model, we connect in series the 2PX and 2PU to get the secondary range, which is 0 to 100 kV. If we connected it in parallel terminology, we get the secondary range 0 to 220 kV. So for the earth terminals and the XO need to be joined because make the circuit complete and no floating occurs. So the circuit will be complete. This instrument specific for 50 to 60 Hz only. Uh, the three cable, red, yellow and blue, need to be connected to L. L1 is a red, this is a red, and yellow, the L2 is a yellow, and the L3 will be the blue wire. So these three cable need to be connected with the PE. With the PE. So this PE is act as an ground for the input cable. It's for the protection. And for the input protection, there is a three varistor between the three phases, and the PE, which is this one, and this one. So all this need to be connected with the to be connected with the ground also.
For the trace and alarm circuit, as we can see on the circuit, there are three switches and normally open, which is switch 1 connected to the red indicator, switch 2 connected to green indicator, and another switch 3 is connected to horn. This three switch is in normally open and it will be triggered if the call in any switch triggered and changed from normally open to normally closed. As we can see on the side view of Kit FC cabinet, there are two out terminal blocks for lamp and alarm system. For the red circle, it is only for auxiliary lamp and alarm, where it is connected to special cage system. On the bottom aqua blue circle is on instrument out terminal block for lamp and alarm system. This lamp and alarm system require special cage because of safety requirement, especially for student and lecturer. In the next slide, I will explain interlock system, which it is used to monitor the door to the HV part of the system and to monitor if the ground rod is taken out from the high voltage. It can also be a door in a safety fence mounted around the HV part. As we can see in the schematic circuit, there are two switches where connected to the door and the ground rod. The two switch is in normally open and the system will start if both of switch change from normally open to normally closed. For the yellow circle is an interlock out terminal. The function of this terminal block is for the safety features. The interlock is connected to the control unit and there is limit switch on the side of the control room door. The function of limit switch is to make sure the system cannot start until the door is fully closed. The red lamp is showed red until the door is being closed. For the next slide, I will explain about the emergency stop, which works with a dual channel operation. It will monitor the discrepancy time between the two contacts and it has a cross-shot detection to prevent connecting the two circuits together in a fault case. From the circuit, we can see the two switch which is in a normally closed. It connected from cable 1 and 3 to the emergency button with key. For the side view of kit FC cabinet, there are two up terminal blocks for emergency stop button in the green circle. The emergency stop button is connected to the control unit in the control room to ensure the safety requirement. It takes immediate action for the student get an error when do an experiment. Thus, the emergency stop button is automatically activate the grounding switch when got an error on the instrument. For the next slide, I will explain about the grounding system. As we can see on the schematic circuit, there is 6 cable which is connected to cable 1 is connected to GND, cable 2 is connected to switch is in grounded position, cable 3 and 4 connected to 24 VDC, cable 5 is connected to switch is in underground position, and cable 6 is connected to 24 VDC switch. All 6 cable is connected to GND switch. The ground switch is switched to ground position. When software status is HV off or power off, it is always ungrounded when software status is HV ready or HV on. This instrument using copper braided. To make sure the grounding have low potential, the resistance had to be low value. The grounding of this instrument should not be mixed with the grounding of this building because the instrument had to avoid from ground loops. The grounding should be less than 2 ohm resistive. In IEE grounding in education, less 5 ohm can be acceptable. Use jump to lower the resistance at grounding if the resistance is more than 20 ohm.